Afternoon. I'm Spot On Weather, meteorologist Matthew Euler, and welcome to my latest video. And this one is going to be called Oh Frozen Night. It's Oh Frozen Night. You know, we think about the Christmas carols this time of year, and then we've got Santa Claus here with his elves in the workshop, getting ready for the big day. Just wanted to throw another Christmas themed picture here to start off this video. We got the Old Frozen Night, and why am I titling it Old Frozen Night? There's quite a bit of cold air that's coming our way for the Christmas holiday, and let's get right into the discussion. There's a lot of interesting changes that have occurred since the last video I made a couple days ago. We're going to start off with looking at the ensembles and the latest changes to those. So let's get right to the discussion here. Let me just start off with a quick introduction here. So on the left-hand graphic of each slide I'm about to show you, that is the GFS ensemble. And on the right side graphic of each of these slides I'm about to show you, this would be the European ensemble prediction system, the European ensemble. Okay? And just again to reacquaint you with the coloring scheme on these graphics, wherever you see the green, the purple coloring, the blues, that indicates anomalously lower heights. And with lower heights in the atmosphere, we typically have colder temperatures. We typically have more unsettled weather conditions. Wherever you see the browns and the maroon colors, bright oranges, that is associated with upper level ridges. And ridges in the atmosphere correspond to milder temperatures, sinking air motion in the vertical, and general dry conditions. So looking at the GFS ensemble left, European ensemble right, this forecast is for this upcoming Monday, the 19th of December, 2022. And so a couple of the main features we're looking at on both of these ensembles would include this upper level ridging across the northeastern Pacific. We have a very strong anomalously high height center over western portions, the northern portions of the Bering Sea, working their way northward. We additionally, downstream of this anomalous high height center, we have troughing associated with this green coloring, generally over southwestern Canada. And then we have a little bit of weak ridging occurring by Monday across the Midwest. And then downstream of that, we got another deep trough. Now this trough is going to be one that's going to make things really cold, specifically on Sunday, right on down from New England down to the East Coast, down to the Mid-Atlantic. That trough is going to move off to the northeast. And then above all of this, over just to the west of Greenland, we still have that west space negative NAO. We have upper level height, higher height center there. So we still have that negative NAO going on. Both of the models in fairly good agreement with the placement of these features. You see the anomalous high height center, very similar, Bering Sea working its way northward towards the Arctic. On the EPS here on the right, the European ensemble on the right, very identical looking placement of the overall trough, the closed upper level low at 500 millibars as compared to Jeff's. It is a little bit further to the west on the European ensemble, but in general, generally stamped in the same location. We see weak ridging as well on the European ensemble, and we see that trough, generally that upper level low around the vicinity of Nova Scotia with a blocking pattern over the top with a negative NAO. Moving ahead now to Wednesday, the 21st of December, 2022. We see now, by the time we get to midweek next week, we have that troughing, which is now extending towards the southeast, from southwestern Canada, working its way towards just south of Hudson Bay at this point in time. And so we have troughing taking effect here. One other major change you'll notice is this upper level ridging now off the west coast of the United States and off the west coast of Canada. We see upper level ridging extending northward with the ridge axis. We generally have that negative NAO, the upper level high height center again situated where it has been for the most part. I apologize for that. Hit something there. And then finally we have generally a very deep upper level low and a trough across the North Atlantic, basically further to the southeast from the NAO, negative NAO, the blocking pattern there, west of Greenland. So in general, here are the main features that I pretty much labeled here at the bottom of this slide. Generally looking at strengthening closed low over eastern Canada, right in this area here. There is one big difference here on the European ensemble. Notice how this upper level low sort of stretches out more west to east orientation on the European ensemble as compared to this GFS ensemble here on the left. There's a little bit difference in that orientation of that closed low height center. We do again see the negative NAO in both cases. It looks like Jeff's is making the upper level height center a little bit stronger than the European ensemble. So there's a little bit of a difference in intensity. The location is pretty much identical between both ensemble models. And again, we see a major level of cold air associated with upper level low over southwestern Canada right in here. All right, and then the one other major feature, look at the ridging here on the European ensemble on the right. It's generally stronger than what's indicated here on the left with the GFS ensemble, the Jeffs. Now let's look ahead at Friday the 23rd of December. Now things get really interesting here. Look what happens here. So the troughing up here in southern Canada begins to expand and move to the southeast. Here it is on the European ensemble again. It's going to move towards the southeast, and look at how much deeper this trough is along the eastern U.S., specifically digging down into the Ohio River Valley in the mid-Atlantic by Friday morning, the 23rd of December. This is the GFS ensemble, the Jeff's depiction of the upper air pattern next Friday. Notice the upper level ridging. The higher heights are still off the U.S. West Coast. In association with this deepening trough here, we're seeing very frigid air which is invading the eastern U.S. by next Friday morning, the 23rd of December, specifically the mid-Atlantic and the southeast. We still see the signature of the negative NAL on both of these ensemble members. See this? The higher heights again, west of Greenland in both cases here. The GFS ensemble on the left and the European ensemble on the right. Look at this. Look at this. Negative NAO continuing. There's also positive height anomalies, as I mentioned, associated with this. There's a closed upper level high situated just to the west of the Southern California area with a ridge axis extending just off the west coast of the U.S. So we have that positive PNA kicking in. We got a deep trough downstream across the eastern U.S., producing very frigid temperatures. If you notice, the European ensemble is stronger in intensity, deeper with the trough, and greater with the height anomalies there across the Ohio Valley. There is also the same kind of setup as far as positioning goes with the Jeffs, but it's not as deep as it's being depicted here on the European ensemble. So very frigid air is coming. That I could tell you. Moving ahead to Saturday, the 24th of December, 2022, the Jeffs model here on the left. Santa is going to have a chilly, chilly, chilly sleigh ride from the North Pole down to the United States. There's a very deep, anomalously low heights, a very deep upper level low situated over southeastern Canada. We've got a deep trough in place, no matter if we're looking at the GFS ensemble on the left or the European ensemble on the right. Very, very intense, deep trough, a very deep cold core low here situated over southeastern Canada. And to the west of that, we have the upper level ridging that is continuing, and it looks like it strengthens here between next Friday the 23rd and Christmas Eve. This ridge starts strengthening, and so you're getting higher height anomalies across the western portion of the United States. And you've got this blocking over the top continuing, negative NAO continuing all the way till next Saturday, Christmas Eve. Look at this. This ridge just poking up the highest heights, the ridge axis to the west of Greenland. You have that blocking high still situated up over the Arctic, the North Pole area. This is just a real impressive pattern. Blocking here, a deep trough here. So the frigid air mass is definitely in effect. I would say starting next Friday, the 23rd of December, that's our first really cold day across the eastern U.S. And then also on Christmas Eve, looking very frigid, much below normal for sure. Now, moving ahead to Christmas Day itself, next Sunday, the 25th of December. These are the latest ensemble model forecast. Again, the ridge, positive PNA existing along the west coast of the United States in both models. You got the deep trough downstream of that ridging, deep trough over the eastern U.S. And we look at the European ensemble here on the right. This thing extends, the source of Arctic air extends from right around Hudson Bay all the way down to the Gulf Coast. All the way down to the Gulf Coast to Interstate 10. Down to Florida. Okay, so you can kind of see by the green coloring here, These are stronger anomalies as far as the lower heights. The European ensemble, again, indicating more intense synoptic features, upper air features, as compared to the Jeffs. Moving ahead now to the day after Christmas, Monday the 26th of December, 2022. Very similar situation. Now, it does look like on the Jeffs that ridge kind of flattens out along the U.S. West Coast, but you still see the blue coloring here across the Midwest, down to the deep South, down to Florida, up the eastern seaboard. It's blue. That means we have lower than normal height anomalies associated with colder than normal temperatures. We got warmer than normal temperatures out here in the west with the ridge. And the ridge is, again, the European ensemble showing a more intense ridging or higher heights as compared to the GFS ensemble, the Jeffs on the left. And also, you see the European. This ensemble is having a tendency to keep a deeper trough, denoted by these darker blue colors across the southeastern U.S. up to the Ohio Valley. We still see, now this is interesting here, right? This negative NAO continues right through Christmas Eve. It continues right through Christmas Day. It continues right through the day after Christmas. So if this block remains in place with the negative NAO remaining in place, that's going to basically favor colder temperatures and troughing in the eastern U.S., that negative NAO period. And you'll have the warmer temperatures out west with the ridge. Now, I wanted to really delve into the operational models today. Boy, these are causing a lot of angst on social media. And I know everybody is just like, especially yesterday after looking at the models, everybody was getting so excited about the potential for an East Coast winter storm at some point between 22 December and 24 December. This is the latest 12Z midday model runs, some operational model runs. I'm going to show you GFS. So I'm going to walk you through GFS and what it's showing. I'm going to walk you through the Canadian operational model, and I'm going to walk you through the European model control model today. I'm going to basically highlight the differences of what they're showing, and I'm also going to talk about the positioning of the upper level feature, the vorticity, and that shortwave and what it means. Okay, first the GFS midday run, and we're going to start the GFS off looking at a chart here on the left. Blue is the snow and green is the rain. And then, of course, the blue H is high pressure, the red L is low pressure. And the dark lines on here are isobars. Solid dark lines here are isobars. That generally indicates lines of equal barometric pressure at the surface. The more tightly packed the isobars are, the windier the conditions. All right? So, next Thursday afternoon, the 22nd of December, we have an amazingly strong 1060 millibar high over eastern Montana, according to the GFS operational model. We do have a deep trough that's digging in. These dash lines here, by the way, are thickness lines. The lower the thickness lines get, the colder, more dense and compact the atmosphere is. The red lines, dash lines down here, are associated with milder temperatures. So when you see the blue coloring, the blue dash lines, that means we have cold air. And the lower that thickness value gets, the colder the temperatures get. So we have a digging trough. We have lower thickness values. We have the trough digging into the Kansas, Oklahoma area initially on next Thursday afternoon. That is 22nd of December. We got this sprawling Arctic high at 1060 millibars. Clockwise flow around surface high pressure in the northern hemisphere, ushering in very cold temperatures on very strong northerly winds. Look how packed these isobars are, the black solid lines. We have a little bit of energy here. This is associated with this trough. And then at the surface off the, basically off of Cape Hatteras, we have a weak surface low pressure system with some rain. Some of the rain trying to work its way on shore along northeast North Carolina, southeastern Virginia, and parts of Delaware and southern New Jersey. On here on the right now, let's look at this. The orange colors, we're looking at 500 millibar geopotential heights. That's the solid dark lines represent height contours in the atmosphere. And then these, the wind barbs are on here as well, indicating the wind directions and speeds. And then the orange coloring, the deeper the orange coloring gets, the stronger the positive vorticity. Now, why is this important? The more intense or higher the vorticity, positive vorticity values, the greater the more energy this upper level trough has to work with. The more deeper the orange, brighter the orange colors. So when I see this kind of feature here, look at this bright orange coloring here with a piece of energy dropping down the northern stream across East Kansas down to Oklahoma. By this point, it's sitting right here. This trough is digging on the GFS operational midday run. All right, a little bit further downstream over the western Atlantic, we have a little bit of weak ridging going on. We have a little bit of higher heights over here. Now let's move ahead. This is Friday the 23rd of December, Friday morning. And look what happens. Let me go back. This piece of energy at 500 millibars or 18,000 feet, associated with positive vorticity moving in, associated with this trough axis, a short wave. Ahead of those short wave trough axis, you get rising vertical air motion, and you can kind of see a reflection of that energy in the middle atmosphere over here on the left with the blue coloring the snow across the Midwest. Look what happens by Friday morning the 23rd, next Friday the 23rd of December. Wow, this thing closed off. Look at the image here on the right, the graphic on the right. We now have a closed upper level low. See the dark solid line here? It's completely encircled or enclosed. And it's situated over southern Tennessee, northern Alabama, into northern Georgia. This is a very deeply digging trough at this point. We got 540 height values, 540 decameter height values all the way down to almost the Florida panhandle at this point. This is a lot of energy. This is a lot of vorticity, a lot of energy. And then look what happens as a result of this energy moving over the baroclinic zone, the area that divides the Arctic air from the milder air. It kicks off an area of surface low pressure, generally off the just along the South Carolina coast by next Friday morning, the 23rd of December, according to the operational GFS model. So according to this model, we got a lot of rain from Florida working its way up to Georgia, the Carolinas, all the way up through the Virginia coastline. And just inland of that, we got some heavy snow, which is extending all the way down into the deep south, Alabama, eastern Tennessee, Kentucky. We got a really good storm cranking up here. That pressure starts off around, I think that's 995 millibar low. And that's due to this energy in the mid-levels of the atmosphere kind of just dropping in there. Closed upper level low already. Moving ahead now to Friday the 23rd. Actually, I did that twice, didn't I? Yes, I did. It's a little bit later in the day. That's why I did it. Okay, so now we're moving ahead to Friday afternoon. This was Friday morning. This is Friday afternoon. Now, Friday afternoon, this low continues to deepen or intensify right off of the North Carolina coast. And we have heavy snow going on across parts of western Maryland down through western Virginia, working its way down towards the higher elevations of North Carolina, the Asheville area, working its way down towards the western portions of South Carolina. We get a nice 1037 millibar high, clockwise flow, just bringing in that cold, very cold air from the north on the backside of the storm system. And we got a lot of rain still going on along Carolina coastlines and Virginia coastlines up to DC area as well as Delaware. Look at this vorticity. This thing is completely enclosed, completely closed off. It's situated now the 500 millibar low, generally over South Carolina. Let's keep going. Now we move ahead to the forecast for, this would be basically next Friday evening after sunset. And now we have a 971 millibar low. We got a lot of dynamics at work here. We got very heavy snow on the backside of this low over a large chunk of Virginia up to Maryland. And now it's starting to spread a little bit further to the northeast to southeastern Pennsylvania by this point. Very heavy rain offshore, just basically getting wrapped around this intense cyclone. And then over here on the right, showing you the 500 millibar geopotential heights and the vorticity again. Look how darkly shaded this is, how high these vorticity values are. Look at the scale here on the right. These are the vorticity values. And it's a completely enclosed low right over southeastern Virginia by next Friday evening after sunset on the 23rd of December. We see a transition of heavy rain over to snow into the coastal sections of North Carolina and Virginia as cold air is wrapping around this system. Again, there's that closed low over southeastern Virginia next Friday evening, the 23rd of December. Now, let's keep moving along. This is overnight now into the wee hours of the morning, Christmas Eve morning. That low is just really, really intense. I believe it's 965 millibars. I think that's that. But these isobars are so tightly wound around this thing. Very intense low pressure system just off the South Jersey coast. We got extremely heavy snow going on from New York State right on down to parts of Jersey, eastern Pennsylvania, including the Philadelphia area, down to Washington, D.C. at this point. Just a very intense and dynamic system. Very cold Arctic air wrapping it on the backside of it. The thickness values are just crashing on the backside of this intense storm. And then look at this. Look at this enclosed or basically closed off low there off the New Jersey coast by next. This is early morning hours on Christmas Eve morning. Now, what's the Canadian show? Now let's compare. So we saw what the GFS is showing. It's showing, and by the way, the GFS operational has been sticking to its guns. I just went and looked back at this earlier today, and there's 7 straight model runs from the GFS operational up through 12Z today on the 16th of December that have something like this for a track. And a very intense low pressure system, potential blizzard conditions here in Virginia and up the coast. What does the Canadian model have? All right, the Canadian model today, midday run, basically has this Arctic frontal boundary moving in. This is next Friday morning, the 23rd of December, and it has all the moisture basically streaming up ahead of this Arctic front. And so places like Virginia, Eastern PA, all the way up to New York State and Vermont, New Hampshire, Massachusetts, Connecticut, Long Island, and New York City, it's going to be a heavy rain, just a heavy rain as the winds briefly turn southerly and really pick up in intensity before this Arctic front moves in. That's what the Canadian is showing. Look at where your upper level closed low is at. It's over Michigan on the Canadian model. Where was it at on the GFS? Down here. Down over the deep south, like basically all the way down to northern Alabama and Georgia and South Tennessee. This trough is much deeper on the GFS model as compared to the Canadian model. Look where the upper level low is closed off at, way up over Michigan. Look at where your vorticity lobe is. It's generally extending well to the north. It doesn't even get south of Interstate 40. It stays north of Interstate 40. There's very strong winds from the south ahead of this upper level closed low. And then, around out ahead of the front, that Arctic front, you're going to have that surge of tropical moisture right ahead of it. So it could be about a heavy rain according to the Canadian model along the East Coast in the same spots that we're showing this on the GFS model. Now I haven't looked at the 18Z GFS just yet, so I'll take a look at that after I cut this video. Here's continuation of the Canadian operational. The Arctic front is now pushing off the coast. By Friday afternoon, early afternoon, next Friday, the 23rd of December, we got an intense low wrapped up over here over the Great Lakes. Very frigid air is now pouring southeast towards the East Coast by this point in the Mid-Atlantic by next Friday afternoon, the 23rd of December. And then all the dynamics are generally further north. They're getting heavy snow in eastern New York State by this point in time. And look at where your vorticity is. Look at where the lobe is, way up here over the Midwest and Ohio Valley, wrapping around this strong upper level closed low over the lower portion of Michigan. And then finally, I did a couple more takes of what it looks like here on the Canadian. This is Christmas Eve afternoon on the left of the Canadian, showing the storm departed well off to the northeast, and now it's just cold and dry. Low thickness values in place, a deep trough is situated across the Eastern U.S. by Christmas Eve. And then over here on the right is actual Christmas Eve itself. This was Christmas Eve afternoon. This is Christmas Eve itself. 516 decameter thickness values according to the Canadian, all the way down to Western Virginia and Eastern Tennessee. It's going to be freezing. That is for sure. We got a 1031 millibar high situated near Houston, Texas, right around the Galveston area, rather. You're going to get extremely cold air. The freezer door is basically open by this point. Now, let's take a look at the European model, the operational model today, 12Z, midday run. Look at what happens here. This is on the left here, I'm showing you the thickness chart for next Friday morning, the 23rd of December, and it's very similar to the Canadian. We got a lot of moisture streaming out ahead of this strong Arctic front. We do have an area of lower pressure further north over western New York State in the vicinity of Buffalo, New York. at 983 millibars. And we got this very strong Arctic front, the tight thickness packing here across parts of Western Virginia, Western North Carolina, Western South Carolina, all the way down to the Gulf Coast next Friday morning, the 23rd of December. All right, and we got the rain and moisture similar to the Canadian model up ahead of the Arctic front. We got most of the dynamics, heavier precip up here in New England, mainly rain though initially, out ahead of that low pressure system over western New York State. This is all the warm sector. You're going to have a strong push of a strong low level jet of southerly winds up here pushing that moisture and that much warmer temperatures briefly out ahead of the Arctic front. And the energy is also spread out over a much wider area in addition here, just like the Canadian model. Look where the closed upper level low is on the European operational run. It's over Indiana. All the vorticity and the vorticity lobe it does dig a little bit deeper on the European as compared to the Canadian. The vorticity lobe itself extends down into Mississippi and Alabama and North Georgia. But look at this thing. The closed upper level low is over Indiana. Now, moving ahead, we go now to Christmas Eve morning. Generally, we have the trough in place. The storm system is now starting to push up to Canadian Maritimes. All the moisture is now offshore. So now we just have a very cold Christmas Eve in store for the Eastern U.S. Look at where your closed low is at this point. We have a very strong closed low, generally around Toronto, Canada, with very cold air with this deep trough, strong northwesterly winds, and westerly winds blowing into the mid-Atlantic. Just very, very cold air. So I want to, again, let's just point, before I move on now to the temperature anomalies, let's just do a recap here, okay? And I just want you to pay attention to this graphic on the right of each of these slides now. All right, so this is your upper level shortwave trough. This is where all your energy is, okay, in the northern stream. Initially, Thursday, December 22nd in the afternoon, it's situated over Kansas, Oklahoma on the GFS. Then it pivots southeast, digs super deep, all the way down into parts of Alabama, Georgia, and Tennessee, kicks off this really big storm system at the surface, and then it just closes off all the way down here over the Carolinas on the GFS operational, that upper level low, closed off over the Carolinas, and then it pivots and works its way up towards Norfolk, Virginia, and then it heads off the coast on the GFS. All right, and then the Canadian has the upper low way up here. It's the furthest most location of the closed upper level low out of all the operational models. Look where it is. And then the European model has it a little bit further south than the Canadian model, but well to the north of what the GFS to operational showing. It's over Indiana. And then it heads up towards southeastern Canada around Toronto. So bottom line here is we have a lot of model discontinuity today. These specifics will change between each model run. All right, now, of course, the big news today is the trend of where the trough axis is setting up, this piece here, has shifted a little bit further west. In other words, the trough axis is that trough is going to dig a little bit further to the west according to the trend we're seeing today in the models. Doesn't mean it's going to stay that way, though. I'm expecting still a lot of changes between now. I mean, look, we're 7 days out from this event, potentially, right? 7 days out, next Friday, the 23rd of December. Right, so there's a lot of time to watch this. There's definitely going to be a storm of some sort. I think everybody's in agreement on that. There's definitely going to be some very strong winds with this Arctic frontal passage for sure. It's going to be a significant drop-off behind the Arctic front. Now, will we get those warming temperatures ahead of it along the East Coast with a strong southerly jet at 850 millibars, a low-level jet? We'll have to wait and see. Or will the Arctic air, will this low pressure form further offshore and this Arctic air come rushing in? When does this trough at 500 millibars go from a positive tilt to a negative tilt? At what point? So there's a lot of questions yet still to be answered is what I'm getting at. Let's go ahead and take a look now at the temperature anomaly forecast. GFS Ensemble first. Barney is there. That purple coloring is Barney there, like Barney the dinosaur. Extremely frigid temperatures in Western Canada. This graphic here for the GFS Ensemble temperature anomalies in degrees Celsius. The purple shading is the absolute coldest or greatest temperature departures from normal on the cold side across Western Canada. This is for next Monday morning, the 19th of December on the left. You do see some colder air over the Eastern U.S. at this point associated with the trough. So you're going to have some colder air still going on across the east on Monday, the 19th of December. Now look what happens with the purple coloring, how it expands southeastward. The Arctic air is on the move at this point. The Arctic front by Wednesday morning here on the right is generally positioned from western New York State down through Ohio, eastern Kentucky, central Tennessee, down to Mississippi, all the way down to Texas. All right, so Texas, it's going to be cold. It's coming. But the very core of this coldest air is stretching across the upper Midwest and northern plain states by next Wednesday morning, the 21st of December. And then bam, 23rd of December on the Jeffs temperature anomalies. Look at how much below normal temperatures are here from the northern plain states down to the Gulf Coast. And then you definitely have some colder temperatures as well, starting to bleed in or spill in from the west across the East Coast. And then definitely by Christmas Eve day. This looks like the coldest day right here, Christmas Eve this year. Going to be very frigid anywhere east of the Rocky Mountains. From the Gulf Coast all the way to the U.S.-Canadian border, it is going to be a frigid, frigid Christmas Eve. Now let's look at the European Ensemble mean. This is the forecast for next Friday morning, the 23rd of December. Look how strongly cold or below normal things are from the upper plains right on down to the Tennessee Valley. That's a little bit different than this one, right? Let's see. Yeah, that is different for sure. So the 23rd of December, very cold. And then the 24th, this is just very cold, period. Again, both these ensemble models are indicating very frigid Christmas Eve. And then here's the forecast for Christmas Day itself on the European Ensemble mean. Purple coloring, the greatest temperature anomalies below normal. Here's a scale on the right here. Okay, so very frigid temperatures in the Midwest to the East Coast, down to the Gulf Coast for Christmas Day as well. And then things start moderating a little bit by the 26th, the graphic here on the right. You'll notice the purple shading isn't as dark. And so it's still going to be very frigid, though, nonetheless, in the same general areas east of the Rocky Mountains. So here's my final thoughts on tonight's video. Let's just put it right here. I've got a lot of final thoughts tonight because there's just so much going through my head right now. First of all, there's lots of uncertainty regarding late next week's storm system. I have not looked at the 18Z GFS yet. So all this data I'm sharing with you off this video, I prepared from the midday model run. Okay, GFS might be completely different here in the 18Z run, and I'm going to take a look at that after this video. But overall, the 12Z GFS model is showing the greatest probability today of wintry weather into the mid-Atlantic and along the East Coast. The European and Canadian models, on the other hand, they're saying no. There's going to be just rain up the East Coast out ahead of the Arctic frontal passage in that warmer sector before the Arctic front blows through. And all that precip's going to fall in the warmer air, and then once the Arctic front blows through, we're going to see drier, colder winds. And the atmospheric column is going to dry really, really quick once the Arctic air blows in. So, in general, that's what we're looking at. GFS is on, some people are calling it on its own island today, and it's true for the midday runs. European, Canadian are saying, nope, it's just going to be a lot of heavy rain ahead of Arctic frontal passage. You saw the positioning of where those upper level closed lows were at, with the Canadian model being farthest north, the European model having the closed low over northern Indiana, and then the GFS had that closed low way down south over Alabama, North Alabama, Mississippi, Georgia area, and South Tennessee. Big difference in positioning of where that upper level closed low sets up. Now, what I've observed in my time in southeastern Virginia, if I bring it back locally to where I'm at, the biggest winter storms generally occur across southeastern Virginia by starting off as a cold rain before transitioning to snow. There has not been, I don't think I can remember one storm that just strictly started off as snow. Maybe January 2018, early January 2018 storm, maybe that one. But that'd be about it. All of them usually start off as a cold rain, and then they eventually transition to wet snow. And what happens when you get a cold rain? You get a wet ground, then that cuts back on the overall snowfall accumulations. And this is what happens. You'll look at the model output and you'll see, hey, we're supposed to get 6 inches of snow, but because of the wet ground, the snow initially melts upon impact to the ground. And so that forecast for 6 inches of snow in reality may only be 2 inches of accumulation. So be mindful of that in the models. They're going to indicate higher numbers or values for snow accumulation. But if you get rain first, that wet ground tends to inhibit any snow accumulation initially. So, yeah, I haven't developed a rule of thumb for this yet as far as model forecast snow accumulations and what you actually get when a winter storm starts as rain first before transitioning. That'd be an interesting thing to pay attention to for sure. Now, the majority of times during the winter months, we see precipitation ahead of approaching cold fronts. Usually the sequence of events across the mid-Atlantic, specifically I'm talking to you in Virginia and I'm talking to you in the Carolinas, you typically see rain, that a stream of moisture ahead of a strong cold front in the winter. All the moisture occurs, all that precipitation occurs in the warm sector where it's just too warm for snow or frozen precip a lot of times. And then what happens is you get the cold front to blow through, and you usually get that colder, drier northwesterly winds in the backside behind the cold front. And that tends to dry the air column, the atmosphere out really quick. And so basically you only get precip in the warm sector ahead of the strong frontal passages. I've seen it. If I were to look at cases, let's just say out of 10 cases, this is going to happen about 7 to 8 times out of 10 times in the winter across southeastern Virginia, all the way down to the Carolina coasts. You're going to get a slug of moisture. It's going to be the milder air preceding a strong cold front. Right now, across where I'm at in southeastern Virginia, the water temps are still quite warm, generally along the mid-Atlantic, just off the Virginia coast. This morning's water temperatures offshore were around 50 degrees still. Now, that's something to take into account when it comes to rain snow forecasting along coastal areas of Virginia specifically. The water temperatures, no doubt, will come down and decrease over the next 5 days because we're going to have relatively cold air in place with highs generally in the 40s and lows in the 20s and into the 30s each day. So those water temperatures are most likely going to drop into maybe the 44 degree or 45 degree range by the end of next week. Additionally, we have to watch the amplification of the upper level trough at 500 millibars. We have to watch this. How deep does this thing get? All right, how deep does this dig? Does it dig like the GFS this far south? Does it just kind of dig right here where the Canadians got it, up here in the Ohio River Valley, just up to that location north of I-40? Does it dig up here near Interstate 80 in Indiana? We got to watch amplification. How far does this dig? How deep does that trough become, the shortwave trough? Okay, that's another thing I'm watching. And where does the main trough axis, where does it dig the deepest? Is it further back west of the Appalachian Mountains toward the Midwest? Is it going to be further east, closer to the coast, the East Coast? These are things that I'm just thinking about today looking at these models. The tilt of the trough, just as important at 500 millibars. If it goes negative sooner, where you have the axis, trough axis extending from northwest to southeast, the storm is going to get pulled back further west. It's going to become more intense sooner, and it's not going to be on the coast. It's going to be further west. And what I mean by the trough axis, this is an example of a negatively tilted trough right here. See how the trough axis is generally extending from northwest to southeast here over the mid-Atlantic on this particular graphic example here on the GFS. The more it extends negative, the greater the stronger the intensity of the storm, and the greater the chances it's going to have a track further west. And we're going to be in the warm sector with rain. Here's another one. Another thought of mine today I was thinking of. Do not trust any of the operational model runs right now. GFS, Euro, and European and Canadian. Don't trust these runs. They're going to keep changing from time to time. Okay? All right, so let's take a look again. And we can just take a look at this. I mean, whether we're talking about the surface feature differences, where the low is, or the upper level closed low, where the energy is, the vorticity lobe, the strongest vorticity. They're all different. This is GFS. All right. That's Canadian. See the differences? And then this is the European. They're all way different, especially with the positioning of the 500 millibar closed low and the vorticity maximum. So, I know it's like a wide range of emotions when you want winter weather, isn't it? You really want that snowstorm, and the holidays are coming up, and then you get the emotions involved with looking at these models, and one run you're ecstatic one run because it has everything you're looking for, right? A nice snowstorm. It's coming up on the Christmas holiday. Wouldn't this just be great timing, right? As far as like for effects, getting the snowfall out the window during Christmas. Don't get yourself too up or too down on one model run, and I know it's hard not to do it. I'm just as bad at it. It's kind of like excitement, but then disappointment, right? You get a good model run where, it favors what you're looking for and you're just ecstatic, like I said. But then the next model run might be completely opposite or has a different trend to it. And now you're just getting cold rain instead of that snowstorm, right? I relate with that. I watch these model runs religiously in the wintertime. But overall, don't. I guess I'm saying don't fret on each passing model run, because most likely 6 hours later it's going to change again, or if it's a European model, really 12 hours later. But generally, it's still too far out in time. These models are going to flip back and forth on solutions. We should have a better handle on the storm track intensity, the thermal profiles in the vertical, the lower levels of the atmosphere, and the precipitation types, rain versus snow, by early next week. Generally, Monday and Tuesday next week, it's going to have a much clearer picture of the synoptic features, where they're located, the placement, the intensity, where that 500 millibar closed low is going to set up, basically set up. So again, don't trust any of the model runs right now. Just kind of take it with a grain of salt. Just kind of get an idea of where the energy is going to be. There's going to be additional chances for storms, by the way, in addition to the one we're focusing on tonight in late December. As colder air is in place, the upper trough remains parked over the eastern U.S. So there could be potential pieces of energy that kind of drop down through the base of that trough. That's going to be positioned over the east. And who knows, we could get something between Christmas and New Year's. The air mass is going to be slow to modify, generally after the 26th of December. It's still going to remain cold enough, though, for wintry precip potential across the mid-Atlantic and Virginia, and generally in the east as a whole, even after the 26th of December. And then finally, frigid air is on the way. That is very high confidence right now. The big storm system that we're talking about in today's models here, whether we're talking about an Arctic frontal system, a strong Arctic frontal passage, or a big storm system, doesn't matter. Frigid air is going to fill in behind either that front or a major storm system. That's going to act to enforce extremely cold temperatures into the base of that trough late next week. To me, it looks like the coldest days are going to be generally what I have listed here, 23 through 25 December. But I really do see 23 and 24 December as the coldest days. But regardless, this period is going to be highs only in the 30s across southeastern Virginia, with lows in the lower 20s. Of course, the further north you go, the colder it gets. Up into New England, for example. We're going to see a tighter pressure gradient setting up. We're going to have very low wind chill values too. That's the other thing with this cold air late next week. We are going to have a lot of wind energy. And we're going to have very strong gusty winds, which is going to result in even lower wind chill values. Your air temperature might be 32 in the morning, but with a wind gusting up to 20, 25 miles per hour, that wind chill is going to be very, very cold, very low. And then again, we're expecting that gradual temperature moderation, 26 to 27 December in general. So the core of the coldest air is going to be here, 23 to 25 December. So no matter what happens, whether we get snow or not, it's going to feel like Christmas outside, okay? The temperatures are going to be nippy. If you got a fireplace, get that fire going. If you have company over for Christmas, you'll be able to just sit there and talk with your company, have the fire in the background, feel the warmth from the fire, play some Christmas music. It's going to feel like Christmas. People are going to be in long sleeves and not sweating. It's not going to be 70 in the mid-Atlantic like some Christmases have been. It's going to feel really like the season. So, if there's one positive we could take out of this, if you like the winter weather, you like it colder at Christmas, it's definitely high confidence that it's going to be a colder period of time here. If we get the snow, I kind of think of that like as bonus, right? If you like winter weather. All right, that's all I've got for tonight. I wanted to just do a quick video, kind of a rundown here. I've got a dog on my lap right now. I think his patience is wearing thin with me as I'm making the video. Anybody who's got dogs out there, you know what I mean. they're basically like, hey, it's time to give me some attention here. So I'm going to go for now, and I hope you enjoyed the video. I'll keep watching things. I do post on Twitter, and I also, give updates on the Spot on Weather website. You can find the Spot on Weather website. Just Google Spot on Weather in Google, and you'll see my site, the Weebly site. And I do a lot of great stuff on the website as well. So if you want to take a look at it, please feel free to do so. All right, everybody. I certainly wishing everybody a happy holidays. Hey, it's Friday night. Have a great weekend, everybody. And until next time, take care and God bless everyone.